Real numbers are mainly classified into rational and irrational numbers. Rational numbers include all integers and fractions. All negative integers and whole numbers make up the set of integers. Whole numbers comprise all natural numbers and 0. We continue our discussion on real numbers. We begin with a very important property of positive integers, that is Euclid's division algorithm. Euclid's division algorithm is based on Euclid's division lemma. So first we will see what is Euclid's division lemma. Euclid's division lemma. A lemma is a proven statement used for proving another statement. Theorem 1. Given positive integers a and b, there exist unique integers q and r satisfying a equal to b into q plus r, where 0 less than or equal to r less than b. You may have also realized that this equation is nothing but a restatement of the long division process which you have been doing all these years, and that the integers q and r are called the quotient and the remainder respectively. Now what will be a and b? A is the dividend and b is the divisor. Euclid's division algorithm. Euclid's division algorithm, as the name suggests, has to do with divisibility of integers. Euclid's division algorithm is based on Euclid's division lemma. It says that any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r that is smaller than b. It is a technique to compute the highest common factor HCF of two given positive integers. Let us state Euclid's division algorithm. To obtain the HCF of two positive integers, say a and b, with a greater than b, we need to follow proper steps. Let's see the steps. Step 1. Apply Euclid's division lemma to a and b. So we find whole numbers q and r such that a equal to b into q plus r and 0 less than or equal to r less than b. Now step 2. If r is equal to 0, b is the HCF of a and b. If r not equal to 0, apply the division lemma to b and r. Step 3. Continue the process till the remainder is 0. The divisor at this stage will be the required HCF. This algorithm works because HCF of a comma b is equal to HCF of b comma r, where the symbol HCF a comma b denotes the HCF of a and b. Let's see one example. To find the HCF of two numbers 455 and 42, we know HCF of two positive integers a and b is the largest positive integer d that divides both a and b. Let's find the HCF of integers 455 and 42. We start with the larger integer, that is 455. Then we use Euclid's lemma to get 455 is equal to 42 into 10 plus 35. As the remainder is 35, which is not equal to 0, we need to again apply Euclid's division lemma to 42 and 35. Considering the divisor 42 and the remainder 35, and apply the division lemma to get 42 is equal to 35 into 1 plus 7. You can see that the remainder we got in this step is 7, which is not equal to 0. So we need to again apply Euclid's division lemma to 35 and 7. So with divisor 35 and the remainder 7, apply the division lemma to get 35 is equal to 7 into 5 plus 0. Notice that the remainder has become 0 and we cannot proceed any further. We can say that the HCF of 455 and 42 is the divisor at this stage, which is 7. Although Euclid's division algorithm is stated for only positive integers, it can be extended for all integers except 0, that is b not equal to 0. Let's see one problem. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Let's see the solution. Let a be any positive integer and b equal to 6. As per Euclid's division lemma, we know a equal to b into q plus r, where 0 less than or equal to r less than b. Hence, a equal to 6q plus r, where r ranges from 0 to 6. R is an integer greater than or equal to 0 and less than 6. Hence, r can be either 0, 1, 2, 3, 4 or 5. We will put values of r in a equal to 6q plus r and check whether it is an even or odd integer. When r equal to 0, a equal to 6q. So, we get it is an even integer. When r is equal to 1, what is the value of a? A is equal to 6q plus 1. So, we get it is an odd integer. When r equal to 2, what is the value of a? A is equal to 6q plus 2. It is again an even integer. When r equal to 3, a is equal to 6q plus 3. It is an odd integer. When r equal to 4, a is equal to 6q plus 4, even integer. When r equal to 5, we get a is equal to 6q plus 5 and it is an odd integer. Therefore, any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Hence proved. So, in this section, we have covered a very important property of positive integers, that is Euclid's division algorithm. Euclid's division algorithm is based on Euclid's division lemma. Euclid's division lemma is stated in the form of a theorem. And the theorem was, given positive integers a and b, there exist unique integers q and r satisfying a equal to bq plus r, 0 less than or equal to r less than b. Euclid's division algorithm is a technique to compute the highest common factor HCF of two given positive integers. To obtain the HCF of two positive integers say a and b with a greater than b, we have followed three-step process. Step 1, apply Euclid's division lemma to a and b. So, we find the whole numbers q and r such that a equal to bq plus r and 0 less than or equal to r less than b. Step 2, we have seen if r is equal to 0, b is the HCF of a and b. If r not equal to 0, apply the division lemma to b and r. Step 3, continue the process till the remainder is 0. So, the divisor at this stage will be the required HCF.